All right, this is lab number 5, polarization using Malice's law. What we're going to be doing is we've got a laser beam here shining through a chopper, which is a rotating device, which basically cuts the beam at a constant frequency, interrupts the beam constantly. And here we have a polarizing filter, which can be rotated with a angle marker on it, so we can keep track of what angle it's polarizing the beam at. And here we have a light gatherer, a photodiode, essentially. It's running through this amplifier into this digital oscilloscope, and as you can see, we have a non-tracked. There it is. Okay, now it's being properly triggered, so it's not rotating to the side. Square wave, which is what you would expect from a beam which is being constantly chopped through there. Basically, here you have the points where the beam is shining through, and here you have the points where the beam is not. And one effect that we've noticed is that electromagnetic interferences from our body actually plays a significant role here. So if you notice that as I'm moving around, this is moving. So fortunately, all that's doing is causing a displacement of the wave up and down. And we've actually noticed that that's a little bit more convenient when measuring the total amplitude than messing with the vertical position knobs, because as you can see, there's a slight lag here when you switch around the vertical position, just by nature of the way the digital oscilloscope works. However, if you move your body around, you can get slight manipulations of this thing much more smoothly. And so when reading this, it's much easier to find your center point just by moving your body around and then read it from there. And that's the method that we use. We, each one of us, myself and Andrew Close, I'm Ryan Stottle, by the way, took one set of data measuring the amplitude at various angles in 15-degree increments going all the way around 360 degrees. And we got two sets of data which seem to agree fairly well. Okay, what we're going to do here is we need to find a base level for what the intensity of the beam is in order to determine our HR value. So what we're going to do is we're going to remove the polarizer, and then let's get this level there. So now it's holding still. And we're going to find the amplitude of the beam just by itself. So that looks like 200 millivolts exactly. As a note, we actually do get a different amplitude if we turn the background pollution lights off. But as you can see, it doesn't change the total amplitude, it just offsets it, which is easily corrected for. And now we'll be moving on to the next part.
Okay. I'm going to begin at 0 and take the measurements from there, and we're going to increment at 45 just for the sake of the video, so we don't have to have a 15-minute long video when we can explain it in about 5 to 10. Our first measurement is going to be 100. All right. Our next measurement at 45, that is going to be at 25. At 90, we are getting 30. $135, we are at 120. 180. We are at, again, 120. This measurement is at 20 for 225. For 270, this is at 20. $315, $115, and our last measurement is going to be at 360, just to clarify that nothing's changed throughout the experiment. And this is at 100.